Hello students, welcome to the fifth lecture on the lecture series on probability. So in this lecture, what we'll be covering is, we'll be covering some more exercise problems. So let's start this lecture and do some exercise problems. So let's start with problem number 1. So you have a box with 6 red balls, 4 blue balls, 5 green balls. Okay. So what you have right now is 6 red balls. So 6 are 4 blue and 5 green, right? So this is what you are given. So if you draw 3 balls without replacement, okay, so in the box how many number of balls are there? 4 plus 6 plus 5, so it will be equal to 15. So total 15 balls, right? So you draw 3 balls without replacement. Okay, what is the probability of drawing exactly 2 red balls, 1 blue ball, okay, in any order? Okay, so drawing 2 red balls first will be equal to what? So this can be actually divided into 2 mutually independent cases. Okay, so we can actually evaluate the individual probability of those cases and then sum them up. So let's see the case 1. So case 1. In case 1, first you draw 2 red balls. So 2 red balls first, then following 1 blue ball, right? First 2 red balls, then 1 blue ball. So what is the probability that you will be picking up first 2 red balls and then 1 blue ball? So it will be equal to what? 2 by 15, because there are how many number of red balls? Okay, so drawing exactly 2 red balls. Okay, so it will be actually equal to, so in this case it will be RB. Okay, red and blue, right? So let's see. So it will be equal to what? So it will be 1 by 15 into, it won't be 1, since there are 6 red balls, it will be 6 by 15. Then you will also what? Pick a red ball, okay, without replacement. So it will be what? 5 by 14, because there are now 14 balls are remaining. So then what we have to multiply is how many number of blue balls are there? There are 4 blue balls. And how many balls are there? Since 2 are already picked, there are 13 remaining. So this will be the answer for this case. So case 2 will be what? Case 2 will be red, blue, red. Okay. So for red, how many choices are there? So it will be 6 by 15, right? Because there are 6 red balls and total number of balls in the box is 15 right now. And then you want to pick a blue ball. So what it will be? It will be 4 by 14, because 4 blue balls are there and 14 total number of balls are there, because it is done without replacement. Okay. So then what we need to multiply? We need to multiply 5 by 13. Why? Because 5 number of red balls are already present, because only one red ball is picked up, okay, among the 6. So remaining is 5. So how many balls are total left in the box? So there are 13 balls remaining in the box, because 2 are already picked up. So it will be equal to what? 6 into 4 into 5 by 15 into 14 into 13, whatever it is. Okay, so let's try to see the case 3. So case 3. Okay, so what we can see in case 3? Okay, in case 3 there are what? The case 3 will be blue, then red, then red. Okay, that is, first the blue ball was picked, then after that consecutively 2 red balls were picked. Okay, so what will be the probability that first a blue ball is picked and consecutively 2 red balls are picked? So it will be equal to what? 4 by 15, because 4 number of blue balls are there and total number of balls are 15 in the box, because nothing has been picked up yet. The first ball that is being picked is blue ball. Then what will be the probability that a red ball is chosen after this has happened? That is, we have chosen a blue ball out of those 15. So it will be equal to 4. It will be actually equal to what? It will be equal to 6 by 14, because 6 number of red balls are already there, because only blue ball has been picked, and total number of ball remaining is 14, because already a blue one is picked. So for another red ball, what will happen is there are 5 red balls remaining and total number of balls remaining is 13, because 2 are already picked. Okay, so we need to sum these 3 cases up to get the total probability. So probability total will be, because these are what? Exclusive events. Okay, if this has happened, this can't happen. If this has happened, this can't happen. So we have to sum these up, because only these 3 cases are possible. So total probability will be 6 by 15 into 4 by 14 into 5 by 13, that is the case 2, plus 6 by 15 into 5 by 14 into 4 by 13, then plus what? 4 by 15 plus 6 by 14 into 5 by 13. So this will be the answer. So let's try to evaluate what will be actually the whole answer. So it will be equal to 15 into 14 into 13, and in the numerator what will be happening? So 15 into 14 into 13 will be in the denominator because their LCM is same. Okay, so what will have in the denominator? So 6 into 4 into 5. So it will be 6 into 4 into 5 plus 6 into 5 into 4. Okay, plus 4 into 6 into 5. Okay, so this will be equal to 6 into 4 into 5 into 3 whole by 15 into 14 into 3. Okay, so 4 into this will be 5, right? Okay, so 5 and 3 can be cancelled out with this. Okay, and we can actually cancel out what? We can cancel out 6. So we can write it as 2 into 4 by 14, right? So it will be equal to 4 by 7. So 4 by 7 will be the probability that this will happen, that the probability of drawing exactly 2 red balls and 1 blue ball, okay, will be actually 4 by 7. Okay, so probability of 2 red and 1 blue ball will be 6 by 15 into 5 by 14 into 4 by 13 plus 6 by 15 into 9 by 14 into 5 by 13 plus 9 by 15 into 6 by 14 into 5 by 13. Simplify the expression to get the total probability. So the total probability will become 4 by 7 as we have seen right here. Okay, so let's go forward with problem number 2. So a box contains 10 identical balls. Okay, so all the balls actually look the same. So of which 4 are red. Okay, so they are identical in shape but not in color. So what are their colors? So they are actually 4 red and 6 blue balls. But you can't actually distinguish between these 4 red balls because their shape is what? Same, and their color is same, that is red. Okay, and same goes for the blue ones, that are 6 present in there. Okay, in that box. So you draw 4 balls. Okay, number of balls that you are drawing is 4 balls, and one at a time without replacement. Okay, so you always remember that the two cases are wholly different. Okay, so how you will evaluate with replacement problems or without replacement problems are actually tackled in a very different way. Okay, they are fundamentally different problems. So you can't apply this formula here, which you actually apply with what? With replacement problems. Okay, so please try to consider the keywords, that is without replacement is right here. So we will be actually using the concepts of without replacement. Okay, we won't use the concepts of with replacement problems. So what is the probability that you will draw all the red balls before drawing all the blue balls? Okay, so it asks us that the probability that I will draw all the red balls first, okay, before drawing the blue balls. Okay, so basically it asks us that what? I draw 4 balls. Okay, so how many red balls are there? 4. So basically it asks us the probability that I draw exactly 4 red balls. Okay, so what is the probability that I draw 4 red balls without replacement? So for the first drawing, what will be the probability? It will be 4 by what? 10, right? Because there are 4 red balls present and total number of ball in the box is what? 10. And then for the second case, it will be 3 by 9 because total number of balls remaining is 9 and number of red balls left is actually 3. And then for the next what? Picking, so it will be 2 by 9 the probability, because there are only 2 red balls are remaining because 2 are already picked, and in the whole box also there are only remaining 8 balls, right? So it will be 8, and then it will be 1 by 7. Why? Because the number of balls remaining is actually 7, out of which I'll pick a red ball, that is actually only one is present there because already 3 red balls are picked up. So it will be actually equal to what? 10 into 9 into 8 into 7, and in the numerator what will happen is 4 into 3 into 2. So it will be 4 into 3 is equal to 12, into 2 is equal to 24. Okay, so here we have 24. So in the denominator what we have is 10 into 9 into 8 into 7. So this will be the correct answer. So let's try to simplify this. So 24 by, so actually it is 4 into 3 into 2, right? So it will be equal to what? So this will be 10 into 3 into 2, so it will be 4 into 7. Okay, so cancelling 3 3, and 2. What we are left with is 4 by 10. So we can also write this as 2 by 5 into 2 into 7, right? 2 is already cancelled. So it will be what? 2 by 5 into 7 is equal to 35. So the probability will be what? 2 by 35 in this case. So calculate the probability of drawing all the red balls first. Okay, so first ball red is equal to 4 by 10. Without replacement, probability of second ball being drawn is what? 3 by 9. So probability of the third ball being red, okay, will be what? 2 by 8. And probability that the fourth ball will be red is what? 1 by 7. Without replacement. Okay, all these cases are done without replacement. So calculate the probability of drawing all the blue balls last. That is probability of first blue ball will be what? 6 by 6. Probability of the second ball blue will be what? 5 by 5. Probability of the third blue ball will be 4 by 4. And multiply the probability to get all the red balls and all the blue balls. So sum of the probability for the cases that you draw all the blue balls before. Okay, so it will be equal to what? It will be actually equal to 2 by 35, because after that we have multiplied with 1. Okay, that actually doesn't matter. Okay, because only blue balls are there. So that is why the answer will be what? 2 by 35. So the correct answer will be 2 by 35. So let's go forward with the next question. Okay, and see what it tells us. So in how many ways can you arrange the letters word in the word apple? Okay, so what you need to see here is P is identical, right? Can we distinguish between these two letters? No. Okay, so what will happen is, so the cases where P, P, A, L, E. Okay, so this will be what? Only one possibility of this kind of. Okay, these can't actually permute with each other because these are what? Identical. So what we will consider is, we'll consider this as P dash, a new one. Okay, but these two are considered as one. So if you have what? Actually here you have 1, 2, 3, 4, 5 letters. But in this case, what you have is only one letter. We consider this as 1. So 5. So these two P are 1. So in whole we have 4 letters. Okay, this is what we assume right here. So how many way you can actually permute 4 letters? 4 factorial way, because for the first place there are 4 positions. For the second place there are 3 contenders, and for the third place there are 2 contenders, and for the fourth place there is only 1 contender. So it will be equal to 4 factorial way, right? So in this case also it will be 4 factorial way. We can actually also use another trick. Okay, that is a trick. That is, if you have a word, let's say A, B, B, D, F, F, G. So in how many way can you what? Can you permute these? Okay, so what you do is, you just count the number of letters there. 1, 2, 3, 4, 5, 6, 7. So 7 factorial. First you write this, and in the denominator what you do is, you see how many letters are there that are being repeated. So F is being repeated and B is being repeated. Let's do another B right here. Okay, so it will be what? 8 factorial. Okay, so 8 factorial ways. Okay, so how many times B is being repeated? It is being repeated for 3 times. And how many times F is repeated? Only 2 times. And is there any other letter that is being repeated? No, right? So for B, it is being repeated 3 times. So you will see 3 factorial right here in the denominator, and then multiply with if another number is being repeated or letter is being repeated. So here F is being repeated. So you will do what? How many times it is being repeated? You take its factorial and multiply right here in the denominator. So you have done this. So what you are left with is the number of way you can actually permute this. Okay, so let's try to see whether it will be same or it will be different, right? Okay, so it will be actually what? 8 into 7 into 6 into 5 into 4 by 2 factorial. That will be equal to 8 into 7 into 6 into 5 into 2, right? So let's try to use this using our methodology. Okay, that we assume all the same letters as 1. So this will be B dash and this will be F dash. So how many letters are there? 1, 2, 3, 4, right? Only 4 letters are there. So how many way these can be arranged? Okay, so these can be actually arranged with 1, 2, 3, 4, 5. Okay, so this can be arranged actually in 5 factorial ways. Okay, so the word apple has what? 5 letters, right? So what we do is we calculate first 5 factorial. Okay, since p is what, repeated twice, right? So we divide it by 2 factorial. Okay, so by dividing it by 2 factorial, what we are left with is 60. Okay, so 60 will be actually the correct answer. So let's see problem number 4. So you have a deck of 52 cards. So how many ways can you choose 5 card poker hand? Okay, that is without regard to the order from the deck. So to choose 5 card poker hand from the deck of 52 cards. Okay, so you use the combination formula or CNR, that is equal to n factorial by r factorial into n minus r factorial. Okay, so basically C52 5 will be what? So this is the what, sample space or the cardinality of sample space 2598960. So what we need to calculate is we need to calculate the cardinality of the event space. Okay, so the cardinality of event space will be what? So this is actually the cardinality of event space actually. Okay, so how we can actually choose 5 card poker hand? Okay, so we can choose it in this many ways. So let's see problem number 5. A group of 8 people is sitting in a row of chairs. In how many ways can you arrange them if 3 specific people must sit together? Okay, so let those 3 people, so let's actually denote these 8 people. So let P1, P2, P8. These are the 8 peoples. Okay, they are actually sitting in a row of chairs. Okay, so in how many ways can you arrange them in 3 specific people must sit together? So let's say P3, P4 and P5 sit together, right? They never go anywhere else. Okay, so in how many way can we arrange? So first we consider these are PDS. So how many people are remaining right now? If we consider this 3 as 1, so it will be equal to what? It will be equal to 6 factorial ways, because there are 5 seats now, because the 3 will be considered as 1 seat. Okay, so for the first we have 6 contenders. For the second we have 5 contenders. For the third we have 4 contenders. For the fourth we have 3 contenders. For the fifth we have 2 contenders. For the sixth we have 1 contender. So 6 factorial ways are there. Okay, but you see in a row they sit together, but they can be also arranged, okay, like among themselves, right? Like P3, P5, P4. This is a case, this is a case. P4, P5 and P3 and so many more. So how many way can be they arrange? So it will be 3 factorial, right? 3 into 2 into 1, because for the first case, first place there are 3 contenders, for the second place there are 2, and for the third there are 3 contenders. So this will be equal to 3 factor. So this is multiplied with 3 factorial to get the total number of ways. Okay, they can actually must sit together. Okay, so it will be equal to 6 factorial into 3 factorial. Okay, so this will be the actually correct answer. Okay, so to arrange 8 people in a row with 3 specific people sitting together, treat those as 3 as one entity. So we have 6 entities in total. So the group of 3 and the 5 remaining individuals. So total 6 individuals, right? If we choose the group of 3 as one individual, right? So the number of ways to arrange these entities is 6 factorial. However, with a group of 3, they can also be arranged in what? 3 factorial ways, as we have already discussed. So the total number of arrangements that is possible is, in this case, it will be 6 factorial into 3 factorial. So let's go forward with problem number 6. So you have a jar with 10 red balls, 5 blue balls and 4 green balls. So if you draw 3 balls without replacement, how many different combinations of colors can you get? So you are drawing 3 balls from a jar with 10 red balls, 5 blue balls and 4 green balls without replacement, right? So total number of balls is equal to what? 10 plus 5 plus 4 is equal to what? It will be 15 plus 4 is equal to 19 balls are there in total, right? So I draw 3 balls without replacement. Okay, I don't replace them. So how many different combination of colors can I get? Okay, because I am drawing 3 balls, I can either get red, 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 right? Red, blue, red, or red, red, blue. Okay, so if I pick 3 different colors, because they are actually available. Okay, so how many different combination of colors can I choose? Actually, I can choose all the 3 different colors. That is the maximum that I can actually choose. Okay, so the answer will be 3. So these are the best possible cases, and actually I can calculate what? different colors, that is 3 different colors. So if you ask me what will be the probability, so the probability will be 3 into 2 into 1 by what? Since in how many way can I actually pick 3 balls out of 19? So it will be 90C3, right? So this by 90C3. So this will be actually the probability that I get 3 different colors. Okay, so let's go forward and see problem number 7. So you have 7 different books and you want to arrange them on a shelf. So however, 2 of the books are series and must be kept together. So how many ways can you arrange the books? Okay, so you have 7 different books and 2 of them must be kept together. So you can actually assume them as one book, right? So what will happen? So now I have 6 entries to arrange. So the entity with the books and the remaining 5, because we have assumed these 2 as 1. So the number of ways to arrange this entity is 6 factorial, but those 2 books can be also arranged in 2 factorial ways, right? For the first position there are 2 containers, for the second position there is 1 container. Okay, so it will be 2 factorial. So multiply these 2 to get the total number of ways. So let's see problem number 8. A committee of 5 people is to be selected from a group of 10 men and 7 women. So if at least 2 men and 2 women must be on the committee, how many different committees can be formed? So to find the number of committees with at least 2 men and 2 women, consider the different scenarios. 2 men and 3 women. So C10 2, C7 3. 3 men and 2 women, it will be C10 3 and C7 2. 4 men and 1 woman, it will be what? How many way can I choose actually? 4 men out of 10, it will be 10C4, right? Or C10 4. So this is multiplied with what? In how many ways I can actually pick 1 woman out of 7? It will be C7 1. And 5 women and 0 women, it will be what? C10 5. So add up these combinations to get the. So adding all these combinations, because these are what? Mutually exclusive, and actually they give us all the cases. Okay, so summing these will actually give the total probability. Okay, so I feel that's enough for today. Thank you.